and Steve Hagen is here with me from Dagan, and we are here to talk about GIPS, GeoKit, Optis, and maybe even a hint or two about DNDC, which are all technologies that Dagan is trying to apply at scale to solve soil health and environmental challenges. Steve, is there anything you want to add?
No, that's perfect. We're a spin-off from Applied Geosolutions. Company started in May.
Yeah,
and
all the next might get to that, right?
Okay, great.
Yeah, so just an overview of the talk here. We're going to go over the company stuff and then some GIPS stuff, and then go over GeoKit and how that all ties into Optis. So as said, we're a new company that is trying to basically promote soil health practice adoption by making it such that its monitoring is verifiable across the continent and global scales. And to do that, we need to take our technologies which AGS developed and then spun out. I guess segue to the next slide for that. And apply them at a scale which they hadn't been applied at before. So to do that, we spun out Dagan last year. And the two core platforms that we use there are Optis, the operational tillage information system, and the denitrification decomposition model. And both of those utilize GIPS on the back end and GeoKit for processing remote sensing data and geospatial climatological data sets. Those are both fed through those platforms to generate soil health metrics and to observe the status of farms. And recently, we applied these over the entire Corn Belt with help from CTIC and the Nature Conservancy. And we covered the Corn Belt for 2006 through 2018, I believe. Is that right, Steve?
Yep.
So next. So these, again, there's the three core technologies, but we're really focusing only on Optis and DNDC a bit here. And Optis provides historical observations and near real-time observations of row crop management practices. DNDC models these practices along with soil information and other management info to estimate the environmental impact of those practices on the soil, atmosphere, water, and crop yield. RDSS also uses GIPS, but that is for rangeland decision support for grazing land managers. So with the next one, we'll get into GIPS more. So we started developing GIPS in 2013. It's Python based. And in 2014, we decided to release it as an open source project because it is built on open source geospatial software. And I don't know, Giselle's online, so she's probably familiar with a lot of those tools. I don't know who else is, but organizations now that are contributing to GIPS development are Dagan, Applied Geosolutions, and Indigo Ag has made some contributions that are nice drivers. Next. So the key idea with GIPS is to automate the critical tedium, the stuff that you have to do right at the beginning of any geospatial analysis project. You have to first retrieve your spatial data sets from providers, and I say here via consistent user interface, because you don't want to have to, have it maintain a script for each data source you have. You want to be able to just say, get me the data for this time and space. And that's critical because various data providers have limitations that you need to respect. Otherwise, they'll ban you from using their data service. And process that data into standard remote sensing products. And then stitch it all together with a mosaic or a warp, so that you take, say, all the imagery over Indiana that comes in separate chunks and make it into one map that you can use for a high resolution time series analysis. Or if you're using farm fields or counties as your spatial extents, then you can summarize those rasters over those smaller extents and use the statistics over the area to estimate or model environmental outcomes. Next. So this is, GIPS has been described by some as a data cube factory. So this is just a quick graphical picture to have of that, where you make your requests via the CLI or the API, and those can vary from just what data is available to actually fetching it, to exporting it, and all the way to creating time series of summary statistics. And I think next we get to an example of that. Oh, no, first, the structure is a driver-based architecture, so it's composed of a framework that has all the classes and functions that are generic and applicable to all the data sources. And then all of the idiosyncratic bits that are particular to each data source get encapsulated in drivers. And those are the projection, resolution, tiling, etc. And then there's the data handler API, which is a subsystem of GIPS that allows you to issue one request via a socket and have it take that request all the way through from a geometry and a date specification to a summarized time series. And with the driver-based architecture, you can plug in any modules, so you can extend GIPS with your own proprietary module, provided you follow, provided you never distribute it. Next. So when using GIPS, there's just some basic terminology that often gets thrown around. There's the repository, which is connected to the idea that, say, you get all of your MODIS data from one source and you keep it in a local repository. Then there's an asset, which is a particular flavor of data available from the repository. And then products can be derived from those assets by the driver's algorithms. And export is both a thing you do and the sort of the directory full of raster data that is exported after you run GIPS export. And then you can summarize all of those by using a command called GIPS stats, which will go through the entire export and compute an array of statistics for you to use for time series analysis. Next. So all of the things that it does there for the up through export, you can basically do in one or two command lines. In this example is just NDVI and LSWI from Landsat, and minimum and maximum temperature and precipitation from PRISM. And if you add the command line --fetch onto this, it will even go and get all the data for you if you haven't downloaded it already. And I guess the structure of the output is kind of important for understanding it when it comes out. There's a directory for each feature in the shapefile that you provide. And it will have a raster per date in there for every date which there's an observation. Next. This is just kind of the graphical picture of the steps that it goes through and how you end up with your data cube. The fetch, like the nested blocks there with fetch, process, and export, those are all sort of one depends on the other, and masks and summaries can be done essentially independent of the rest of GIPS once you've gotten your data set stacked up the way you'd like. Next. So this is just some of the data sources, most of the data sources rather. I realized we left off the HLS, which is the Harmonized Landsat Sentinel-2 dataset that Goddard Space Center started providing last year. But with all of these drivers, the interface is the same. You run GIPS export, like in that previous example, the driver name and the time and space for which you want data, and it will export a nice, tidy directory for you. Next. This is just at the point where you download and install GIPS or grab the Docker image. These are the basic commands to do all those things. And GIPS info is one that's helpful just for providing info about what products are available for each driver. Archive is for the data sets which you cannot fetch. Pulsar and ALOS are two sensors that we've used on occasion that there's no automated retrieval system. And yeah, and the other commands are relatively straightforward. The inventory, GIPS inventory, can be used either just to query or to trigger data to be fetched by just adding on that --fetch option. And process and export they're very similar to inventory in terms of the arguments we have, the time and spatial extent, but you also need to specify on export the resolution at which you'd like the data exported. And there is another option with export, and that is to use a raster grid that you'd like it exported on, and that allows you to ensure that the data lines up pixel for pixel without any shifting around due to different data sources. And mask and stats too, as they are named as well. Next. Oh, right. This is all single threaded. So that's where we come to the data handler and GeoKit. Next. So GeoKit is the extension of GIPS to be a multi-node processing cluster. And that's on the data handler end, and it's connected to a site builder, which is a web decision support tool kit that allows you to log in and create your own DST by walking through some configuration steps. I'm not going to get into the site builder too much here, but the data handler has the catalog service, render, and scheduler. I'm going to talk about a little bit more about that next. So catalog service will list all the variables or products that are available in a JSON such that it can be consumed by another service or published. The other service that is the primary consumer is the site builder, and that's how the site builder knows what's available to put into a DST. And the scheduler manages the relationships to generate the products and get you the time series, and returns it to the site builder or to a user directly if you're using the data handler API directly. And the processing engine can be either Torque or RQ, both common multi-node schedulers, and those computing environments were chosen for sort of government lab, NASA Earth Exchange compatibility, as well as for broader public cloud compatibility with Redis and R2. Next. So the stuff that is upcoming for GIPS and GeoKit is we're currently in the process of porting to Python 3. We started out many years ago. The time has finally come to do that because the clock is ticking on Python 2. I believe Python 2 is end of life at the end of this year. And we are working on untiling GIPS to better support sensors which aren't gridded at the source, aren't tiled. And to expand the supported use cases for GeoKit and the data handler to enable a FarmOS module to monitor a farm at near real time as part of the open tool. And Steve, I don't know if you want to take the time to talk about Optis.
Yeah, I don't know. It might be worth like pausing here and having discussion and answering any questions about GIPS and GeoKit? Or alternatively, we could go all the way through the slides and reserve discussion until then. Dorn, do you have a preference on those?
I think it might be good to pause to talk a little bit about, especially where this intersects with weather data. And I thought maybe there may be some questions, particularly from Ankita, but I won't put anybody on the spot.
Definitely not. I know that you did. One of the questions that I have had so far is just if you could maybe talk a little bit about the different kinds of data sources that you have. I know you mentioned that there is a data inventory command or a GIPS.
Yeah. Steve, you know where to go there? Yeah. This is a list of most of the data sources. And I guess, I don't know if there's any particular, Dorn said weather. Are you interested in weather data?
Well, so one of the groups that I'm affiliated with is putting together a weather API to meet some of our immediate needs. And so, there were about 9-ish specific variables that we were looking for. And so they have been building in the background, and I just wasn't sure if there might be overlap with some of the stuff that you're doing, or if there are maybe recommendations about where I can go explore to be able to figure out what that overlap might look like.
Yeah. I think we, this hits on something we talked about at GO last year, which was getting some sort of ontology together that I think it was JSON LD was the primary candidate for tying things together better, and that would be good for helping in exactly this situation.
Yeah.
But the for climate data, CHIRPS is one that is, I believe that's, I think, Steve, do you recall, is that originally we just had the Africa data set and then it was expanded to global? Or was it, I can't remember, that was from a few years ago.
I'm cloudy. I can't remember.
Okay.
It sounds right.
So I think it is global now, but that's fairly coarse, I think. Prism is just for CONUS, and that provides the min, max temperature and precip amounts. GPM is another another data set that is the global precip. And I think those might, and DayMet and Mera also are two other climate data sets that we have used on the regular. I believe DayMet is probably the one we've used.
So I guess here's maybe a very specific question then. So for example, if I wanted to get frost dates and I was looking for some sort of precipitation data or variables related to something that I could use to calculate a frost date, where might I go within GIPS?
So to do that, you're looking at getting a GIPS export of, say, DayMet temperature data, and then doing a time series processing of that to get the dates which are lower than your frost.
Okay.
Right. So yeah, GIPS export tends to be the go-to because you can have it do everything. Yeah, I guess, and that would tell you any dates that were below that temperature. The question is just if you wanted to do that on the scale of an average over some area, or if you wanted to do it by pixel.
Yeah, so I guess in our case, I would want it probably per county, maybe. I need to talk to my zone teams a bit better to try and figure out what level of granularity we want for that one. But that's at least just one example of the kind of thing that I would be looking for. And so I might want to explore this during our upcoming meeting. So,
Okay.
Cool.
And so that makes it so that you could do either, if you were going to try and do it on the finest scale you could, then you go with the GIPS export and you've got per pixel.
Sweet.
And if you don't need that, then you can export and run GIPS stats for each county directory, and you never have to look at the mess that is the raster pile.
Cool.
Thank you. Anyone else?
Yeah, it's Craig Simmons from Anthesis and Cool Farm Alliance. Thank you for the presentation, very interesting. I just have a question, or two questions really. The first one is, how much are you providing sort of process geodata, and how much are you providing metrics? Because earlier on the slide you mentioned things like soil carbon and other metrics. Do you do those metrics calculations, or just provide the source data for others to do those calculations themselves? That's one question. And the other question was just about performance over APIs.
Okay. So GIPS will provide, I guess, Steve, can you go back to the DNDC Optis RDSS slide? When you say the metrics, I assume you're talking about these pieces here? And,
yeah, the DNDC, yeah.
Yeah. So I think with almost everything here, it's not just something that GIPS pulled out of a remote source. Some of it is, looking at the crop emergence date is under Optis there. That is something that, that alone takes in climate and remote sensing information and uses those to get the best estimate we can of the crop emergence date, depending on clouds and other remote sensing obstacles. And all of the DNDC outputs would be driven by, again, GIPS climate data being fed in to DNDC along with any additional info about management and modeled through DNDC. So it wouldn't be just passing along another source's data. And the other question was?
Well, I guess
sorry, did I answer?
Yeah. No, I think you did. I mean, I had the second question about API performance, but I guess I'm interested in the methodologies used to generate some of these, because some of them I can see how you can generate with satellite data. Others I can't immediately see how.
Oh.
But maybe this is obviously for a longer discussion, and
that's okay. I think that maybe the piece that I didn't state clearly enough is that with DNDC, DNDC itself isn't a satellite-based model. It's a process-based model, so it takes in a description of an area that we've distilled from remote sensing or from first-hand farmer reporting, and estimates those quantities from those inputs.
That makes a lot more sense. Thank you. I missed that. Yeah.
Sorry, yeah.
And I'll add that we'll be doing a special session just on DNDC later in the series. So
yeah,
great. Thank you very much.
To do all in one one go here.
Yeah, and I guess on the API performance, I guess I didn't know which flavor of API you were asking about.
I mean, it's a very general question, and obviously difficult to answer based on the amount of data you want to pull down over. I'm just thinking if we wanted to integrate and pull down some satellite data, obviously one of the challenges we've had is performance, and so have you sort of managed to address that? How have you tried to address the issues around performance and a sort of dynamic use of satellite imagery data?
Yeah, well, I don't know, I would say the extra dynamic use where you don't have much of it stored locally or stored in your own cloud is particularly difficult because a lot of the providers are, single file downloading. But that said, we use, a cache for the data that we can't just download in a massively parallel fashion. And we've found our way through both the Amazon and Google storage stashes of Landsat to be able to pull down from there at a really wide rate, thousands of jobs concurrently.
Wow. Okay. Great. And so you maintain that cache. Yeah.
Yeah.
Brilliant.
Yeah, and maybe not now, but my question was along the same lines in terms of the data explorer side for sort of a very local cache of that information for geo time series data visualizations.
I think for what it's worth, Open Land Map guys, they have sort of a similar strategy.
Yeah, I'm not familiar with OpenLandMap, but I can see how it would be just the thing you must do in order to get it to work. Yeah, I guess any other questions on GIPS or?
I think we should go on to Optis, and then we'll pick up other questions at the end.
Okay. So Steve Hagan, here you go.
Thanks, Ian. And Craig, I think this might fill out the picture a little bit more with some of your questions. I'll just lightly touch on DNDC, and the focus will be on Optis. But as Ian explained, GIPS and GeoKit are open source tools that that are part of almost every one of our processes here, and are a central engine for things we build on top of it, including DNDC and Optis. And here's a little bit of quick background on DNDC and Optis. As Ian just mentioned, DNDC is a soil biogeochemical model. It was developed at the University of New Hampshire and is open source for academic research use, and then there's the commercial license is held by Dagan. It's got a wide research network and many hundreds of publications globally, and I think Ian did a good job describing what DNDC is useful for quantifying, including crop yields and soil carbon and N2O emissions and nitrate leaching, reactive nitrogen. It's important to note that it's a mechanistic model, a process-based model, and not an empirical model. And yeah, stay tuned for a full sort of dive into DNDC from Bill and upcoming part of the series. And then Optis stands for the Operational Tillage Information System, and this is the remote sensing based platform that really has GIPS as part of its engine. We make use of Earth observing satellites. Again, a lot of those sensors that Ian highlighted from GIPS. We integrate information from multiple satellite platforms to put together a picture of a few things. the amount of residue cover that remains on the soil surface at the time of planting, the emergence and vigor of cover crops in the winter, and crop rotations. And you know, there's quite a bit of literature on both mapping residue cover and green cover. We're not the first people to do it, but we did, I think, take kind of a step forward in our ability to apply these algorithms over broad, you know, large areas without requiring individual sort of parameterization of each satellite image in a particular area at a particular time. And that allows us to make, you know, relatively accurate estimates over wide areas for pretty cheap, because we rely on freely available government remote sensing data primarily. And we can also, this is done at the farm field level and sub-farm field level, so we can look back in time theoretically to the beginning of the Landsat TM era, but in application we've only gone back to 2005, and so that's the overview of those two technologies. But again, GIPS stands at the center of that as sort of the heart or engine of Optis, and then the Optis algorithms that map the residue cover in the winter cover crops, those are algorithms that we essentially post-process the remote sensing data to create these information products. And this is a general slide just that sort of gets, I think, Craig, to your question about, like, we're not remote sensing soil microbes, but we're using the Optis information about management at the farm field level and using that as input into a soil biogeochemical model to get a fuller picture of soil health, and the aspects of that are laid out here. Ian also mentioned recent work that we've done with the support of the Nature Conservancy and the Conservation Technology Information Center, and that was to apply these two technologies across the Corn Belt, defined as Land Resource Region M, and that's sort of this like green area that touches 14 states, and we took Optis back to 2005, and we mapped tillage practices estimated based on the amount of residue cover left on the surface at planting, and cover crops, estimates of cover crops, and crop rotations, and looked at how the adoption rates of those soil health practices changed between 2005 and 2018, and then used that information again at the farm field level as input into the DNDC model to estimate changes in N2O emissions, SOC, water holding capacity, and nitrate loss. And just want to emphasize that, again, Optis works at a fundamental sort of mapping unit of 30-meter pixel scale. We then aggregate that up to what we call farm segments, field segments, and that's the unit at which we then run the DNDC model. And for public release of the data, we then aggregate up to the crop reporting district and watershed scales. And those data from the Optis are now available on the CTIC website. I think I've got the link at the top there. And in about a week, the DNDC results will be available at that website as well. But we also create field scale products. On the Optis side, we construct field boundaries, these field segments that I referred to on the previous slide. We construct those and define those as contiguous units of area with common crop rotation history and management practices back through time. Right now, for the Corn Belt, we focused only on the crop history to create the field segments. But we also produce estimates of residue cover and tillage practice at the farm field scale, cover crop metrics, presence and absence of the cover crop, as well as some information on the timing of emergence or winter kill. And we're working on adding estimates of cover crop vigor. We also provide information on crop emergence and harvest dates. And again, that information is useful if we go to the center box as input into the DNDC model, and that DNDC model can then provide, more complete information on soil health and environmental outcomes, again, like SOC and greenhouse gas emissions. And we're working to build up our, analytics on top of simply sort of data tables of results, and allowing folks to evaluate optimal management at the field scale, or diagnose performance of a field in the context of its neighbors and that sort of thing. We're also pretty interested in how some of these, conservation practices affect crop resilience when it comes to drought or flooding, as well as the gap in yield between potential yield and what a farm field actually sees. And here are just a couple of images that give you a sense of the sort of products we make. This is the larger images here are just an example of some winter cover maps at the pixel scale, 30-meter pixel scale. I think this is in Minnesota. But we separate winter commodity from cover crop. The winter commodity here is in brown, and the cover crop is in green. But you'll also see some of the riparian areas show up that meet the same sort of criteria that the cover crops do. And so, yeah, the algorithms are sensitive to that. We also make maps of crop residue cover and convert those to estimates of tillage classes. And I'll show you a little bit more of that in a second. Here's a time series that gets a little bit into, the GIPS output, includes time series information, as Ian highlighted. In this case, we're in the blue, we're showing both observations from the Landsat series of satellites, as well as Sentinel-2 A and B. And the green line is similar, but we've fused Landsat and Sentinel with MODIS observations at the 30-meter scale to get a more complete time series. And then from that, we can look for indicators associated with conservation practices. And in this case, what we're looking at here is a greening period early in the late winter and early in the spring associated with the emergence of a cereal rye crop that was then terminated just a few days later, and you can see that very distinctly in the time series before the summer crop was planted. This is just an example of a residue cover map, and here we're showing from brown through yellow to green. We're looking at the amount of crop residue on the soil surface at planting time in the spring of 2018. We're able to then dig in a little bit, and this example shows some CLU boundary data, but as I mentioned, we also make our own field segments that are based on common crop histories, and that helps us. Often CLU data are boundaries that are more from a sort of tax or sort of broader financial management, and don't get necessarily to agronomic management of the field. And so what we see here, it's not the best example, it's hard to see, but in the darker blue you see a CLU boundary for a field, but in fact there was different management going on in the field, and the field was split into a north and south section. And you can see in the lighter black, a north segment and a south segment. The north segment not having a cover crop in this winter of 2017-18, but the south segment having it. And very similar thing in this field here, where, again, a single field, according to CLU, but our information indicates that it's separated in management into a north and south component, half of it having a cover crop. And we can then extract crop history information, corn soy rotations. In this case, these two fields were set off from each other. The north and the south were offset. They're both corn soy rotations, but the north having corn in 2017 and the south having soy. And then information about how successful the cover crop was, as well as some information on the amount of residue cover at the time of planting, including some confidence information and timing information. We can then, as I mentioned, aggregate those estimates up to watershed and political boundaries and report on those. And this is an example, again, from the southern half of Minnesota, the part of Minnesota in the Corn Belt, where we see relatively low adoption rates of cover crop in 2018, of the use of cover crops up through 2018, so 2008 to 2018. Still, overall, the acreage is pretty low in this area. It's about, it goes from a fraction of a percent of adoption to about 3% adoption in 2018. And then, as I mentioned, we'll get into this in the DNDC side, but then we can link at the farm field scale. We can link information on practices to outcomes. In this case, SOC. SOC on this field, given the Optis observed management history from 2005 through 2017, versus an assumed sort of counterfactual scenario where on the same field, no conventional tillage and no cover cropping was performed, and a picture starts to fill out of the benefits, potential benefits of conservation practices. I think that's it. Yeah, so I think we have a few minutes for some questions on this, if folks have them.
I've
There
put
are a
a
number on the in the chat window if you want to read them, since we actually don't have the chat being recorded. Do you have access to the chat window, or would you like me to?
I do. I can read a couple here. So I'm going to ask, what's the resolution of the Optis information in that leftmost?
Yeah, I see that. Okay. I finally pulled up the chat box. So yeah, what's the resolution of Optis? So as I mentioned, I'm getting, if people could mute, that would help my, so yeah, we integrate information from multiple satellite sensors ranging from 10 meters to 500 meters. And we chose a unit of analysis of 30 meters for these applications. And so we either upscale or downscale all observations to 30 meters. Are the analysis techniques used to make the different classifications published or available for us to digest? So there are two sources here. We did a pilot in Indiana, and there's an associated report with that, but we're putting together a more complete documentation associated with this Corn Belt application, and that will be made available on the CTIC website in the coming week with the distribution of the DNDC data. And then, so then the next question is there a place we could go to see the set of cover crop data? What terms do you use for crop vigor? Do you have data on the start, end dates, species, et cetera, et cetera? What is the set of data? So for the Corn Belt application, the cover crop information was limited to presence or absence of winter cover, but that was then separated into 5 subcategories, including commodity, which is primarily winter wheat, and then cover crops, which were divided into full cover crop, which meant we observed a canopy both in the fall and in the early spring. A winter kill category, where we saw the canopy of the cover crop in the fall, but did not reemerge in the spring, and then the inverse of that for spring emergent, where there was no sign of a cover crop in the fall, but we did detect it in the spring. And so those are all categorical. We're working on more precise information on emergence date and ways to make that information available. And in terms of vigor, we have information on fractional cover, but are working on linking the remote sensing observations sort of more directly with DNDC crop growth model to estimate the biomass of the cover crops, because obviously the cover and the biomass of the cover crops are going to give us a lot of information about how the soil is protected from erosion, as well as how much of the nutrients are immobilized during the winter. So that's not available yet, but that's in the works, partly with some support of the USDA SBIR program. Are you doing cover crop classification in early stages, or what point do your images saturate? Can I get more information on that question?
It's me. Hi. I'm still sort of a little bit trying to still learn more about remote sensing and cover crops. And one of the impressions that I had was that when using images of landscapes with cover crops, you can only really sort of detect things like biomass and even sometimes species when you have at different stages. And so I'm just curious to know sort of the timing of the images that you're using for these different classifications.
Yeah, it's a great question. So we take every observation that comes from MODIS and Sentinel and Landsat, and we're working to integrate some radar remote sensing as well. We take every image we can get across the year. Obviously, for cover crops, our focus is generally, depending on the area, is on harvest time up through the spring and early summer. So we'll take every observation we can get. But you're right. At some point, the signal of greenness saturates, and if you go beyond that level, you're getting less and less relationship with biomass. And that's where I mentioned just briefly linking the observations more directly with DNDC. We see some promise in doing that to use weather information and the model to overcome this saturation issue that I think you're hitting on.
Yeah.
And then a real challenge for us is the species stuff. Obviously, if we can separate leguminous cover crops from non, that's pretty important. And at this stage, it's something we're working on, but I don't have anything to report on in terms of a slam dunk on that. It's really challenging for us.
Cool. Thank you.
And I imagine that's something that we'll be able to help contribute when we have field level data, sort of ground truth.
Exactly. Yeah. That's a huge thing. Is so much of this is limited by the limited amount of field observations that we've got.
We've got a couple more questions. We're at the top of the hour here, but if you're willing to keep going, it'd be great to get another 2 questions in here.
Sure. Yeah. Sorry that I've been a little long-winded. I'll try to pick it up.
No, no, it's great. It's great.
Okay.
As long as you can keep going.
Yeah, yeah. I think I'm good. I have another meeting at 2, but I can join that a couple minutes late. Is the CLU reference you made, is CLU spatial data from the Farm Service Agency? Yes. It's right, and I guess it was public up until 2008, and then it went behind a wall. There are some companies that provide that data. I'm sure others on this call, maybe everybody knows more about that than I do, but yeah, in partners that we work with, they often supply CLU data to us and ask us to summarize things on that level. And it's just sort of a word of caution to folks that often there's multiple segments within a CLU feature with different management going on in that. Yeah, so then seems like a partner for Regen Network, especially the watershed level monitoring. They have some interesting ideas, ecological improvements, things like watersheds, cities, counties. Are any farm management tools using this data right now? Seems awfully useful. If so, which ones? So no, I think the answer to that is we are currently not providing this information to any farm management tool, and the O team is a great opportunity for us to really start to do that. But yeah, we're in talks with a lot of different potential partners about ways to make the most use of this data, because I think we've done a lot of the hard work, but in some ways not so interesting work to create the data. I think the really interesting things are what come next. What are the relationships that this information can help us explore? And so, yeah, we're excited about that. How much info do you think will be provided by satellites in 15 years, daily, weekly, hourly? What level of detail will it be super cheap? I think you could get a better answer to that from other people other than me. I mean, obviously the technology is improving, at a rapid pace, and we're excited about some of the new instruments, the geostationary instruments, that they're coarser resolution, but they provide they're sort of stationary in providing continuous looks over the continental United States right now. And we have not integrated data from GOES, but I think it's on our list of things to look at. And obviously it's really exciting. We've done some work with planet data, but not enough. We're really continue to be focused on the freely available sources of satellite data. One, because typically this resolution of 10 to 30 meters is useful enough to get good information at the farm field scale and sub-farm field scale, but also because it's free and it keeps the cost way down compared to purchasing data from some of the higher resolution satellite data providers. Have you tried Optis outside of the US? How applicable is it? Other climates, ecoregions, do you need to calibrate it in order to apply it, let's say, to the Argentine pampas? So all of our work has been within the US, and most of our work has been in the Corn Belt. We've applied Optis out in a few other areas, including in sort of the Wheat Belt, in the Mid-Atlantic states a little bit, and in the South a little bit. The bulk of our work, though, has been in the Corn Belt. The system is designed to be picked up and put anywhere else, because we derive information about seasonality from, we sort of do this meta-analysis first in the system, where we derive seasonal information from primarily the MODIS sensor, get parameters from that, and then apply that in the region. So theoretically, we can pick this up and drop it anywhere. But we're hyper cautious about that, and definitely a big component of what we do is we developed a mobile app that allows partners to go out and collect some roadside survey information that gets uploaded to our database. So especially when going to a new area, we check our estimates against field-based information, roadside information, and occasionally do some tweaking, especially if it's a cropping system that we haven't interacted with much before. But we're excited to continue to try to expand out across the rest of the U.S. and then internationally as well.
Well, thanks, Steve. I know you have another meeting to go, and but thanks for the great presentation, and we'll really look forward to diving deeper in DNDC.
Okay.
For the next
great, and yeah, thanks very much, everybody, for the opportunity and for the great questions.
Yeah, thank you, everyone.
Thank you all.
Okay, bye.
Bye.